So this is, what I'd like to do is review the basic concept, okay? Let's solve number 8 and then, there we have it, right? And all we're going to do basically is just add on to this thing, right? So the basic concept is F equals ma, right? F is, in general, F is a sum of a bunch of forces, right? So there's force 1 plus force 2 plus force 3. So this could be, 3 minus 5 plus 2 or something like that. If they're all in one direction, we can do that, right? So that's the sort of thing that F is. And so in these problems, one of the times, like if you've got a mass hanging on a string or something like that, the force down is always the weight. So that's m times g, and we figure that out. And then we just solve it the way we did, okay? Sometimes they give you a force maybe on the level, right? And there's a force this way, and then I say, well, there's a friction force of something, like there's a friction force. We exert 5 newtons of force, but there's a friction force of 2 newtons, right? And on those problems, you say, well, the force is 5 minus 2, yeah? Yes? Yeah. Okay. Now, all we're going to add today is the notion that I don't have to tell you what the friction force is. You can calculate the friction force, right? So we're going to calculate it from things like the weight of the object and the roughness of the surface, and then that's about it, okay? And then mass, the only thing going on with mass is that it's got to be kilograms. So if they give you grams, divide by 1,000, right? If they give you newtons and you're on Earth, they've given you the weight, which is not the force of gravity, which you guys all got right on the test. Pat yourself on the back. Now pat your neighbor's back. No, I'm just kidding. Don't do that. Okay. If they give you newtons, divide by 9.8, that'll give you kilograms, right? Okay, so if they say it's a so many Newton object, well, then they're giving you the weight. Don't fall for that, right? It's not the mass. And then for acceleration, it's like, oh my gosh, we've learned how to calculate acceleration. It's a is change in velocity over time, right? It's v final is v initial plus a times t. It is vf squared equals vi squared plus 2ax, right? It is x is equal to vit plus 1/2 at squared. So that's the whole thing there, right? So to make these problems hard, okay, this is going to be, by the way, the height of our sophistication today is that you're going to have to solve one of these tricky little kinematics problems to find the acceleration. It's going to be positive or negative, right? And we've got to put the positive or negative in there, right? It's like, okay. Then there's going to be we're going to be sliding to the right, so the friction is to the left, so therefore it's negative. We have to calculate that, and then there's maybe another force or something in there that we have to calculate. That's going to be the height of our sophistication. The only thing that would make it harder is that I give you like mass in grams. Oh, divide by 1,000, okay. All right. So number 8 says, oops, I'm on the wrong side. A 60-kilogram rocket accelerates upward from rest, reaching a height of 23.4 meters in 33.00 seconds, right? So we draw a high school safe rocket, yes? Yes? All the edges are sort of angular, yes? Yes? Yeah, never draw like a rounded rocket with like flames and stuff coming out of the bottom of it. Kind of kids all, anyway. Okay. It accelerates upward from rest, reaching a height of 23.4 meters, right? Initial velocity is 0, right? Okay, in 3.0 seconds. All we care about is A, by the way. We don't care what its final velocity is. And I guess this is the one to do. Is that the one to do to find A? Yeah? Yes. So we're lazy. All we care about is A. That's the one that we'll find A. What does A end up being? Is it 5.2? 5.2, okay. So we figure out A is 5.2. Oh, it's like right there, okay. And then we've got this thing now. So, okay, so we've done the SUVOT, right? We do the SUVOT. Now we're ready to do F equals ma, okay? And so we've got it accelerating upward at 5.2 meters per second squared. It is a 60-kilogram object, right? What are the forces acting on it? 312. Well, hold on. There are two forces. The net force might be 312, okay? But there are two forces that add up to 312. What are they? 588, the force of gravity. Which way is gravity? Gravity's down, right? So this force, right, 60 times 9.8, the 588, that's down. I'm going to make it negative. What's the other force? The thrust of the rocket, right? Okay, so that force is up, and it's got to be longer. It's got to be a longer arrow than that one, so like that, yes? Okay? Okay? So there it is, and that force I'm just going to call F. Okay? And now we're set. We can calculate what that force is. I need some space. I'm buying some space here, right? Okay? F minus 588. Those are my forces. Remember, unknown forces are always positive, right? F minus 588 is 60 times, and then is it accelerating up or down? Up. It's accelerating up, right? 5.2, so this guy's positive, yeah? And when you do that, you get, and there it is right here, right? You get 900 newtons, exactly. There it is. 5.2. Yeah? Is that cool? That's cool. So that's like as hard as we get. Today we're going to do the same thing, only it's going to be on a level surface. And then instead of calculating the weight, you'll calculate this friction force. That's where we're headed. So that's exciting.